All right, welcome to the next new chapter. We're going to start chapter 9 today, and this is section 9.1 part 1, and we're going to start talking about right triangle trig. Okay, so what is trig? Trig is basically the study of triangles. Okay, so that's basically what we're going to talk about. And what we're going to learn in this particular section is we're going to evaluate how to evaluate trig functions of acute angles. And we're going to be able to find unknown side lengths and angle measures of right triangles. Okay, so what are we going to do? What are we going to use to solve some of these things? All right, so right triangle, trig function definitions. Let theta be an acute angle of a right triangle. So remember, acute angle just means less than 90. The 6 trigonometric functions of theta are defined as follows. Okay, so we have 6 trig functions. We have the 3 normal ones that you should remember. So we have sine, we have cosine, and we have tangent. And then we have 3 new ones called cosecant, secant, and cotangent. And they're no different than the original 3. They're just reciprocals. So notice that sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. Secant is the reciprocal, hypotenuse over adjacent. And then tangent and cotangent, opposite over adjacent, adjacent over opposite. So all they are is opposites of each other, or reciprocals, I should say. Okay, so let's look at what we have here. We have a right triangle. I'm going to label this right triangle, and this is how the right triangles are always labeled. The angles, we use capital letters. So, and it doesn't matter which one you call which. So I'm doing this capital A, angle B, and angle C. And then what we have is across from those angles are the lowercase sides. So angle B is on the far right. Little b would be the side across from it. Angle A is up at the top. Little a would be across. Okay, so that's how we label our triangles. Now, more importantly, what we're looking at here is we're talking about, so all of these are sine of theta, cosine theta, tangent. Every time you have a problem, they'll give you theta. Okay, so here's theta. And theta is never the right angle. It's always one of the 2 acute angles. Acute meaning less than 90 degrees. All right, so what do we have here? So here's our theta. And what we need to do is we need to label this triangle based off of this theta. So across from theta is the opposite side. Across from the right angle is hypotenuse. You should already know that. And then next to theta, so here's theta, the side next to theta is called the adjacent side. Okay, and that's where we get these opposite over hypotenuse, adjacent hypotenuse, and so on and so on. So the easy way to remember this is called chief SOHCAHTOA. Okay, so down here at the bottom right corner, we have something called chief SOHCAHTOA, SOHCHTOA, and that's the easy way to remember sine, cosine, and tangent. All right, so sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. So that's how we remember it. SOHCHTOA. Okay. Now the question is, how do we remember which one goes with which? How do we know opposite or sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent? Well, the easiest way that I can think of to remember it is that S always must go with a C. So cosine goes with the S. So C goes with S, C goes with S. Tangent, cotangent, those are easy. You should remember that those go together. Okay, so we'll work more with these in a second, and we'll get more used to doing these. All right, so it says find the 6 trig functions of theta. All right, so here's my theta. And now what we're going to do first is we're going to label our triangle. Across from theta is the opposite. Across from the 90 is the hypotenuse. And then next to theta is the adjacent. Okay, so we need to work with all 3 of these. All right, so the problem is, though, we don't know the hypotenuse. We're going to need to use the hypotenuse to solve for some of these. So what we need to do to find the hypotenuse is use the Pythagorean theorem. So remember that a squared plus b squared equals c squared. So the 2 legs squared is equal to the hypotenuse squared. So we have 12 squared plus my other leg, which is 5 squared, should equal our hypotenuse squared. All right, so let's see here. We have 144 plus 25 is equal to c squared. 144 plus 25 is 169, which equals c squared. And then what I do is, to get c by itself, I take the square root of both sides, and I do the square root of 169, which you should know. But if you don't, we can go over to the calculator, we can figure that out. Square root of 169 is 13. Okay, so 13. So our missing side is equal to 13. Okay, now we should be able to do all of our trig functions. Okay, let me get rid of this. Let me get rid of this thing here. I don't want to get rid of that. So maybe I should just use my eraser. There we go. All right, so we're gonna do our 6 trig functions. So let's recall sine. So if we want to write this down over here, sine is SOHCAHTOA, SOHCAHTOA. Okay, so sine is opposite over hypotenuse. All right, so what's our opposite over what's our hypotenuse? Our opposite, we've already labeled this, it's easy now. Opposite over hypotenuse, 12 over 13. Okay. And then cosecant, remember sine goes to cosecant, is just the reciprocal, 13 over 12. All right, cosine. Cosine is adjacent over hypotenuse, a over h. So our adjacent is 5, our h is 13. So 5 over 13. And then remember, cosine goes with secant, so this one is just the reciprocal, 13 over 5. Okay, and last but not least, we have tangent. So tangent is opposite over adjacent. Opposite over adjacent. Opposite is 12, adjacent is 5. And that would make cotangent 5 over 12. Okay, so you have to find the missing side first, and then you do your 6 trig functions based off of chief SOHCAHTOA, SOHCAHTOA. All right, so let's try here. Let's try example 2. It says, in a right triangle, theta is an acute angle and has a sine of 4/7. So they're telling you that the sine is equal to 4/7. And don't forget that sine is equal to opposite over hypotenuse. Okay, so we know 2 of the side lengths of our triangle based on this. So if we come over here to our triangle, here's our theta. Here is the side opposite. Here is the hypotenuse, and then this side would be the adjacent. Okay, so we know 2 of those sides already, so let's label those 2 sides. We know that the opposite is 4, so I'm going to label the opposite 4, and we know the hypotenuse is 7, so I'm going to label the hypotenuse 7. So what we need to do now is we need to figure out the adjacent sides. We need to figure out that 3rd side. Okay, so let's do the Pythagorean theorem. So we have a squared plus b squared equals c squared. So our 2 legs are a and b. Well, we know one of them. We know 4 squared. We don't know the other leg, so I'm going to just label it b squared. And c squared we know, which is 7 squared. All right, so we have 16 plus b squared equals 49. Okay, so let's see here. So let's subtract 16. Subtract 16. So b squared is equal to 49. Take away 10 is 39. 39 take away 6 is 33. So square root both sides, we get square root of 33. Okay, so we have square root of 33. All right, so there's our 3 sides. We should be able to do our other trig functions now. So we know sine and cosecant go together. So if sine is 4 over 7, let me remove these circles now. We don't need these anymore. All right, so if we know that sine is 4 over 7, we know that cosecant is 7 over 4. Okay, so 2 of the 6 are done. Cosine is adjacent. So remember, SOHCAHTOA. So cosine is adjacent over hypotenuse. Adjacent is root 33. Hypotenuse is 7. So root 33 over 7. And that would make my secant 7 over root 33. And then last but not least, we have tangent. Tangent is opposite. Okay, so opposite over adjacent. Opposite is 4, adjacent is root 33. So 4 over root 33, which would make then cotangent root 33 over 4. All right, so 4 of these are done. Root 33 over 7, that's a good answer. Root 33 over 4 is a good answer. And hopefully you notice that secant and tangent, there's an issue. Okay, we can never leave a square root in the bottom of a fraction. So to get rid of it, we just multiply by whatever that root is on the bottom, on the top and the bottom. So let's see what we get here. So 4 times root 33 is just 4 root 33. And then square root of 33 times square root of 33. Hopefully you remember from the last class that that's just equal to whatever the number is. So 4 root 33 over 33 is that one. Then we're going to do the same thing over here. We're going to multiply by root 33 over root 33. And here I get 7 root 33. And on the bottom I just get 33 again. And as long as you can't reduce everything, that is completely done. All right, so there are our 6 trig functions. All right, let's try this one now. Now it says solve for x in the following triangle. All right, so we're trying to figure out what this side length is. Okay, we can't do Pythagorean theorem because we don't know 2 of the 3 sides, so we can't do that. So we're going to set up a trig function. Okay, so I'm going to remember that. I'm going to remember my chief SOHCAHTOA over here. So SOH, CAH, TOA, and we're going to see which one we can use. Okay, so we're going to use the angle that they give you as our theta, and then we're going to label our triangle. Across from the 90 is the hypotenuse, and then the side right next to the angle is the adjacent. So we have hypotenuse and adjacent. So which of the 3 trig functions, sine, cosine, or tangent, uses adjacent with hypotenuse? Okay, hopefully you see that this one does right here. Okay, so cosine is adjacent to hypotenuse. So that's how we're going to set it up. So cosine of our angle is 30 degrees, is equal to our adjacent, which is x, over hypotenuse, which is 8. Okay, so our goal now is to solve for x. So I'm going to put this over 1 to make our life a little easier here. And basically when you have 2 fractions, so we have a fraction on the left and a fraction on the right separated by an equal sign, we can cross multiply. So x times 1 is x. Cosine of 30 times 8 is just cosine of 30 times 8. Okay, and what do we have now? It says x is equal to cosine of 30 times 8. All right, well, this is just a calculator problem. Now, the thing we have to make sure is our calculator is in degrees, because this is 30 degrees. So notice my calculator right now is in radians. So to get there, all you have to do is hit mode, and then check and make sure you're in degrees. So if it's not, go down to degrees, hit enter on it, and then we'll be shit to go. So second mode will take you back to the home screen. So the problem says x is equal to cosine of 30. So cosine of 30 times 8. And make sure you close your parentheses on the 30. And that gives us a 6.93. 6.93 because I'm going to round. So 6.93. And notice that x equals 6.93. That's fairly good. Remember, 8, 6.93, that seems like a reasonable answer. If you got something like 100, okay, you should notice that that probably isn't going to work. Okay, so, but that is reasonable. Okay, so let's do one more and then we should be good. All right, now this one says solve for x in the following triangle. All right, so once again now, my x is up here now though. So I'm going to label my triangle. My theta is 45. Okay, so across from 45 would be the opposite, and then across from the 90 would be the hypotenuse. Okay, so which of our 3 trig functions, so I'm going to write it down again, SOH, CAH, TOA, which one of our 3 trig functions uses opposite and hypotenuse? Okay, so hopefully you see that it's sine. So set up your sine. Sine of 45 degrees is equal to opposite, which is 6, over x, which is the hypotenuse. And then put the sine of 45 over 1, so we have a fraction. All right, now we're going to cross multiply again. So this one's a little bit harder. So 6 times 1 is 6. Sine of 45 times x is sine of 45 times x. Okay, now this one's a little different because x is not by itself. If you notice on the last one, x was by itself. X is no longer by itself, so I need to do something to get the x by itself. So this is multiplying, so the opposite of multiplying would be to divide. So I'm going to divide by sine of 45 on both sides. And sine of 45 over sine of 45 is 1. I'm left with x is equal to 6 divided by sine of 45. So basically we just go to our calculator. 6 divided by sine of 45 degrees. Oops, that's not supposed to be there. And then once you're done with that, hit enter, and you get 8.49. Remember, round correctly, 8.49. 8.49. Okay, so our hypotenuse is 8.49. And hopefully that makes some sense. Always round to at least 2 decimal places. If you want to go 3, that's fine, but 2 for sure. Okay, and that takes care of section 9.1 part 1. We'll finish the rest up in the next installment. See you tomorrow.